Experiment versus Model by Emily Cahill. For my experiment, I used a smooth stone ball, 5/100ths of a meter in diameter, rolling across a level surface. I then used Tracker to analyze the movement of the ball by extracting the position and corresponding time. From that data, this graph of the ball's motion was created. I used the data from Tracker to find the initial conditions of the ball. The start time for the motion was 0 seconds, and the ball's initial position was -1,000th of a meter. I used this data to calculate the initial velocity of the ball by first calculating the displacement of the ball. To calculate the displacement, I subtracted the initial position vector from the position vector after one frame. To get the velocity, I divided the displacement by the change in time, which was 0.033 seconds. This gave me the velocity of the ball, which was -0.48 meters per second. I then used VPython to model the data extracted from Tracker. To do this, I first set the initial conditions of the ball in the computational model to the initial conditions I calculated from the ball in the experiment. Then I set the net force equal to 0, assuming that the ball is moving at a constant velocity. Next, I set the condition for the while loop to 0.433 seconds, which is the length of my video clip. I then use Newton's second law to calculate the new velocity by plugging the initial velocity into the equation final velocity equals initial velocity plus net force divided by mass times change in time. Then I use the velocity calculated from that equation and plug it into the equation final position equals initial position plus velocity times change in time. This gives me the new position of the ball. Lastly, the time step is added to the total and the process is repeated. Each loop creates a prediction of data that is saved and reflected in the outputted graph that shows the predicted motion. The physics concepts I used in my computational model were Newton's first and second laws. Newton's second law states that an object in motion will stay in motion unless acted on by another force. In the computational model, we assume that the object is moving at a constant velocity, which according to Newton means that the net force is 0. Therefore, I set the net force to 0 in the model. When we look at the generated model, we see Newton's first law, which states that if the net force is 0, then the velocity is constant. The velocity of the model is consistent. Because the velocity does not change, acceleration is 0 as well, eliminating the need for mass in the equation. The results, which I will now review, reflect these laws. Here is a comparison of the data extracted from Tracker and the data predicted by the model. As the arrows show, the prediction was almost accurate. The data from the model was within 10% of the experiment data. The accuracy can also be seen with this graph, which compares the data from the experiment in purple to the data from the computational model prediction in red. In the first tenth of a second, the computational model accurately predicted the position of the ball. Right as the time hits the 1/10 of a second mark, the computational model starts to diverge from the experiment results. Some reasons for this could be that the ball drifted a bit, which may have skewed the data in the experiment. I will wrap up by answering a few discussion questions. Discuss briefly how your results would change and how they would remain the same if you were to flip the axes. If the axes were flipped, the only thing that would change would be the direction, which would be positive. The magnitude would not change because the ball is still going the same distance. The next question is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case you observed? I believe it is not possible to say how many pushes and pulls are added together to give 0 net force in my experiment because there are some external forces that I cannot calculate, such as air resistance acting on the ball or friction given off by the surface, in addition to the force of gravity acting the ball. So this is not possible. Thank you for watching.